This is an interactive Punnett square to show us patterns of inheritance of a recessive genetic disease such as cystic fibrosis. In these examples, we're going to be looking at the chance that a child will have the recessive genetic disease cystic fibrosis, and also looking at what are the chances that the children might be carriers or heterozygous for cystic fibrosis allele. Let's start with mating two unaffected parents. These parents are both homozygous dominant, and when we mate them, we find that none of the children end up having cystic fibrosis and none of them are carriers. 0% have cystic fibrosis. Now let's take an unaffected parent and mate it with a carrier. And remember, a carrier is a heterozygous individual. They are not affected with the disease, but they carry the diseased allele in this recessive allele right here. Let's mate these two parents. And again, you can see that although two of their children or half of their children could be carriers of cystic fibrosis allele, none of their children actually are affected by cystic fibrosis. Now let's take a carrier parent and mate it to another carrier parent. Neither of these people are affected, so what are their chances of having an affected child? A recessive disease results when offspring inherit two copies of the recessive allele, one from each parent. So in this case, one of the four possible combinations of children actually have cystic fibrosis. You can also see that half of the children end up being carriers of cystic fibrosis. Now what happens if we mate a carrier with an affected individual? What are the chances that they have a child with cystic fibrosis? 50%, and 50% of their children end up being carriers. And lastly, let's look at what happened if we mated an affected individual with another affected individual. So two people with cystic fibrosis had children. In this case, you would see that 100% of their children would have cystic fibrosis.